So guys, welcome to our channel once again. In today's video on our WAEC Physicism Revision series, we have here these 10 WAEC repeated questions to answer on the topic motion. So guys, this video will be about simple ideas of circular motion. So in short, stay till the end of this video. Let's go ahead and start with the first question here. It says, the angular speed of an object describing a circle of radius 4 meters with linear constant speed of 10 meters per second is. Alright, so guys, here we have the radius and then we have the linear speed, guys. So if we want to get the angular speed, we have to relate it to the equation. Linear speed is angular speed times the radius, so that's v is equal to omega r. So if we want to get the angular speed, which is omega, we divide v by r. So here we'll divide 10 meters per second by 4 meters. So guys, if we do that, we're going to have 2.5, and that's option C here, guys. So that's it for this question. Let's go ahead and consider the next question, guys. So guys, the next question we have here is question number 2. It says, a stone is thrown horizontally with initial velocity 15 meters per second from a tower 20 meters high. How long does it take to reach the ground? So guys, if we use the equation h is equal to half gt squared, so we are going to have that the h is given here, which is the height of the tower, 20 meters, and that's equal to 1/2 times the acceleration due to gravity times the square of the time. So guys, here we are looking for the time, so we'll make it the subject of this equation. So in this case, we're going to have 2 times the height, which is 20, then over g, which is the acceleration due to gravity. So that's t squared. So t squared is now equal to 40/10. So t squared becomes 4, and then t alone will be square root of 4, which is 2. So guys, option A is the answer to this question. Let's go ahead and consider the next question, guys. So guys, the next question we have here is question number 3. It says, a ball is projected horizontally from the top of a tower, neglecting air resistance. Which of the following statements about its motion is/are correct? We have I, vertical acceleration on the ball decreases as it falls. II, the vertical force on the ball remains constant. III, the physical speed of the ball increases as it falls. So guys, the answer to this question here will be the II and III. So that relates to option B here. So guys, option B is the answer to this question. And that's it for this question. Let's go ahead and consider the next question, guys. So the next question here, question number 4, says, an object of mass m moves with a uniform speed v round a circular path of radius r. If its angular speed is omega, the magnitude of the centripetal force acting on it is. Alright, so guys, the centripetal force is always given as F sub c is equal to mv squared over r. So that's option C here, mv squared over r. So that's it for this question. Let's go ahead and consider the next question, guys. So guys, the next question we have here is question number 5. It says, a body is rotating in a horizontal circle of radius 2.5 meters with an angular speed of 5 radians per second. Calculate the magnitude of the radial acceleration of the body. So guys, for this question here, the radial acceleration is actually going to be omega squared r, where omega is the angular speed and r is the radius of the path. So guys, if we take this, we're going to have omega squared to be 5 squared, and that's 25. Then when we multiply 25 by 2.5, we're going to have 62.5 meters per second squared, and that's the radial acceleration here. That's option C, guys, and that's it for this question. Let's go ahead and consider the next question, guys. So the next question we have here is question number 6. It says, A ball swung in a horizontal circle of a center O with a constant speed. What is the direction of its acceleration? So guys, actually when you swing a ball about a center and at a constant speed, the ball tends to move towards the center, and that's towards O here. So option D here is the answer to this question. So let's go ahead and consider the next question, guys. So the next question we have here is question number 7, guys. It says, an electron of mass 9.1 times 10 to the power of negative 31 kilograms moves with a speed of 2.0 times 10 to the power of 5 meters per second round the nucleus of an atom in a circular path of radius 6.1 times 10 to the power of negative 11 meters. Use the information to answer this question. Calculate the centripetal force acting on the electron. So guys, for this question here, we are simply going to use the centripetal force here, Fc, is equal to mv squared over r, where m is the mass of the electron, v is the speed here, and r is the radius of the path. So guys, for this here, we have mass 9.1 times 10 to the power of negative 31 times the square of the speed, that's 2.0 times 10 to the power of 6 squared. Then this will be divided by the radius of the path, which is 6.1 times 10 to the power of negative 11. So guys, when we calculate this out, we're going to have 6.0 times 10 to the power of negative 8 Newton, and that's option D here. So that's it for this question. Let's go ahead and consider the next question, guys. So guys, the next question we have here is question number 8. It says, when a body is thrown vertically upwards, its velocity at the maximum height is. Alright, so guys, this is a very simple question for you all to know. You know that at maximum height, velocity tends to be 0. So when a body is thrown vertically upwards, at the maximum height, the velocity here will become 0. And that's it for this question. Option B is the answer to this question. So let's go ahead and consider the next question, guys. So guys, the next question here, question number 9, says, which of the following sketches represents the velocity time graph of the motion of a stone projected vertically upwards and allowed to return to the point of projection? So guys, the answer to this question obviously here is option C here. So you see the velocity increases with time here, and at a certain point the velocity starts dropping till it gets to the end of the velocity. So that's it for this question here, guys. Option C is the answer. Let's go ahead and consider the next and last question, guys. So guys, the last question here is question number 10. It says, an object of mass 0.40 kg attached to the end of a string is whirled around a horizontal circle of radius 2.0 meter with a constant speed of 8 meters per second. Calculate the angular velocity of the object. So guys, like we've stated earlier on, the linear speed is related to the angular speed by the equation v is equal to omega r, where omega is the angular speed or angular velocity. So in order to calculate for the angular velocity omega, we'll have omega is equal to v over r. So where v is the linear speed, which is 8 meters per second, and then we'll divide it by the radius of the path, which is 2.0 meters. So guys, when we do that, we'll have 4 radians per second, and that's option A here, guys. So that's it for this question, and this is where we'll end this video for today, guys. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not yet a subscriber. Also, if you have any specific question regarding this video, you can drop your question on the comment section below, and we'll ensure to give you a response. So finally, guys, we want to encourage you to join our YouTube channel community, where we'll post major updates on WAEC examination, guys. You can join this channel community by hitting the join button below, and we'll see you right there. Thank you once again for watching this video, and see you on the next one.